March? So today, any questions that you might have? Lots of new terminology in this chapter, huh? So I know last time we started off, you guys are going, oh yeah, yeah. Toward the end of the class, you're all going, looking kind of worried. Don't worry, you'll get it. You gotta practice the terminology as usual, okay? Understand how the terminology relates to the application, okay? So Lab 2 is up. It's due next Wednesday. Also next Wednesday, you'll get a take-home exam for Chapter 4. You may not work on it with anybody else. If you have any questions, you're to talk to me only, okay? And probably all of Chapter 4 will be due. We'll be wrapping up Chapter 4 today. So it's just 3 sections, okay? But it's, you know, be practicing it, okay? Okay, so last time we were working with the bare data. If you don't have the bare data in your calculator, again, you're going to want the total length in one list, the weight in another. So what we did last time, let's do a little recap. We ultimately want to use the length of the bear to estimate how much that bear would weigh. Okay, that is the goal. That is the goal. So all this other stuff happens along the way, okay? Is that relationship something that is visibly viable? Then what is the strength of the linear relationship? We talked about that, right? So we graphed the scatter plot. We looked at whether or not the data lined up, seemed to exhibit some kind of a linear pattern. Then we tested the strength of that linear relationship that we saw visually by calculating the R value. So the R value is an indicator of, okay, we see this linear relationship. Is it worth proceeding? Okay? And we decided it was. So then we calculated the equation of the line. So the equation of the line, remember, describes, it's a mathematical tool that describes the relationship between these two variables. Okay? Then we graphed and I think when we wrapped up last time, we graphed the regression line with the scatter plot on our calculators, right? So remember, there's a regression handout on my website. You are welcome to access that. So let's go to the calculator. A few of you had some issues with graphing the line with the scatter plot, and I apologize because I always miss the first step and I have to go, no, wait, back up. Okay, so there's our calculator. The first thing that we had to do was to, hang on. Oh, okay, perfect. Come on in. The first thing that we had to do was make sure that we had the scatter plot on the graphic screen. So if you hit graph, you should have the scatter plot there. Okay, so you need that first. Then you also need to run the regression. You do that by hitting stat, just stat, and then one right arrow, and then we go down to number 4. Or you can just hit number 4 on your keyboard. You drag that to your home screen. You enter the location of the bear length, whatever list that might be, a comma, and then the location of the bear weight. And you run the regression, and you should be there. You may not have the R and R squared values. If you don't, there's instructions on that handout that tell you how to get your R and R squared values. For some reason, the calculator turns that that function off, and I'm not sure why it does that. Will someone help her out and let her in the door? Thanks. I didn't get enough chairs today, I guess. Last time too many, this time not enough. I don't know. I tried. Okay, so once you have this output on your home screen and the scatter plot on your graphics screen, you can graph the equation of the line over top of the scatter plot or with the scatter plot. So to do that, you hit y equals, and you want your cursor flashing in front of y1. So this is your equation editor. You're going to capture the equation of the line from the home screen, glue it into the equation editor, and then allow the thing to graph it, okay? So that is, once you are right here, you hit There's, that's right next to your clear button. You go down to number 5. You do 2 right-hand arrows, right, and enter, and then graph. And at this point, you can see that the calculator grabbed that regression equation from the home screen and stuffed it into the equation editor. And then graph, and it'll graph the line with the scatter plot. Okay, so you should have that. Now, if you hit trace, you'll be on the scatter plot. If you look up in the upper left-hand corner of your calculator screen, it tells you if you're on the scatter plot or the line. Okay? If you're on the scatter plot, okay, you can see the little cursor blinking. Then you move your left and right arrows, and you scoot up and down the actual data values, and the output below tells you which data value you're on. Okay, there's the bear that's 120.5 centimeters, weighs 60 kilograms. Okay, you remember this? We good? Questions? Okay, cool. Then if you hit an up or down arrow, now you're on the actual regression line. It shows you the regression line up above. Now if you go back and forth, you're scooting up and down the regression line, and for every estimated bear length, you're getting the corresponding, or no, let me rephrase. For every bear length, you're getting the estimated bear weight. Does that make sense? Okay, so remember, this is very, very applied, okay? Now, if we want to, say, estimate the weight of a bear that is, say, I don't know, 160 centimeters long, your cursor needs to be on the regression line. You just type in 160, hit enter, and at this point, we're estimating the weight of a bear that is 160 centimeters long. That bear would weigh about 128 and a half kilogram, right? Kilos, right? Okay? So the calculator is going to do everything pretty much for you. We talked about residuals last time, right? Yes? So residuals are what? Somebody tell me. Go ahead, Mike.
It's the amount of space that a point is away from the line.
Yeah,
basically, like, it's the line, can't represent all the points. Basically, it's just the ones that didn't make it to the line.
Yeah, good one, very good. Yeah, so, now, remember that the line is an overall estimation of what's going on with this relationship between bear length and bear weight. Okay? Now, the points don't line up perfectly, and we discussed that doesn't really happen in real life. That we're just kind of getting an overall model or representation of what's going on here. So residuals are the vertical distances between each point and the line. So every point that isn't exactly on the line has some error associated with it, and that's okay. I know, when you get to statistics, you're like, error? Well, that can't be good. Well, it's okay. In statistics, it's okay. X doesn't have to be exactly 4. It can be 4 plus or minus, okay? Okay, so yeah, we talked about residuals. We talked about how to get them, right? You take the observed, which is the y value at a certain data point, and you subtract the predicted. So you plug in, so you get a data point, let's say, okay, so you get a data point, and we want the residual. We want the residual. Okay, at this data point, the bear's 138 centimeters, he weighs 60 kilograms. Okay, this is the observed Y. Does it make sense that it's the observed Y? Because it comes from the data. You observed it. It's what got recorded. Okay? So take that value, write it down, 60. I'll write it down over here. Okay, so it's the predicted Y No. It's the observed Y minus the predicted Y. Okay, so the observed Y is right here. And the predicted Y is the Y value on the line when X is 138. So how do you find that? Somebody tell me how we're going to find that. Go ahead. Courtney, right?
Yeah, you have your cursor on the line and you type in 138.
Perfect. So we're gonna scoot onto the line, okay? And then we're gonna type in this value of X. And there's our predicted Y. And you can see it is vertically right above that observed Y. Vertical distance. It's vertical distance. Yeah, Lauren?
Does it matter where on the line you put it at?
Yes. Yes, it's always vertical distance. That's why, okay, so this is our observed Y, right? And the predicted Y is the Y at the line for the exact same X value. The exact same X value. So they're both going to line up under that specific X value, or over that specific X value, I should say. So our predicted Y there is 91, let's say 91.3. And that gives us an overall residual. What's that subtraction? 31 point, negative 31.7? 0.4? 0.4? How did we get 0.4? Did you use more decimal places?
Yeah.
Okay. What do we get with 0.3? Come on, you guys.
Negative 31.3.
Oh, it is 0.3. Okay, 0.0. 31.3. Negative 31.3. Okay, so there's the residual at X equals 138. Does this make sense on how to get it? The observed Y and the predicted Y? Just give me a yes, a no, or a kind of. We good? Or a nod? Okay, Mike?
When I'm at the graphing screen,
Uh-huh.
I can't get it to where